Hello students, welcome to the statistics class. In this session, we shall discuss the next concept of bivariate data, that is regression analysis. Now, consider this example here. If we know that the expenditure on advertisement and sales are correlated, then we may have to find the expected amount of sales for a given advertising expenditure or the amount of expenditure for attaining a given amount of sales. Similarly, if we know that the yield of rice and rainfall are closely related, we may have to find the amount of rain required to achieve a certain production figure. So regression analysis reveals the average relationship between the two variables, and this makes the estimation or the prediction possible. Now, in correlation, we establish the degree of relationship between two variables, how they vary amongst each other. So when x or y both together, how much they vary. So if the answer is more than 0.5, then we say that the variation is in the almost same direction, or it is moving in one direction. If there is no correlation, they will be in the opposite direction. Okay, or there will be no line at all. Now, we establish the relation there, we obtain the answer, but it is the answer just gives you an idea of relationship between the two variables. Now if I want to know what will be the change in the dependent variable if I make some changes in the independent variable. Suppose say x is the independent variable and y is the dependent variable. Now here say expenditure on advertisement and sales. Okay, say sales are dependent upon the advertisement. Okay, now using correlation we establish that there is a relationship between advertisements and sales. Yes, it is true. We also get, suppose say you have a data regarding on advertisement and sales, and you try to establish the correlation there, and you will get the correlation as 0.9. Yes, that's good. It shows that 90% correlation is there between sales and advertisements. So greater the advertisements, greater the sales. That's true. But if I want to predict something, suppose if a company owner may not have an very unlimited budget, okay, but he wants to increase his sales. So what he will do is he will try to predict, okay, if I want this much of sale, then how much expenditure I need for advertisement. Now here what are you trying to do is you're trying to predict or estimate the variable value of one while keeping the other on the mind. Okay, so now sales is also variable, advertisement also variable. So in correlation what we do is we uh, establish a statement that greater the advertisement, better the sales, since they are positively correlated. Yes, but what is that exact figure? In correlation we get the figure of both advertisement and sales together. But if I get a concept, or if it is possible for me to gauge the expenditure so that I can try to achieve the respective number of sales. Okay, so that is possible only by regression. Okay, so regression basically helps in predicting or estimating the future values. So if two variables are given to you, then what would be the effect of one on other, that is their correlation. But in order to achieve the effect, what changes I should do in the independent variable? This concept is regression. This is the difference between correlation and regression. In correlation, we establish the relationship between the two variables, but in regression, we try to find out if one variable has changed at a certain extent, then what will be the change in the other variable separately. Okay, so regression analysis reveals the average relationship between the two variables and helps in the prediction. Okay, the term regression literally means return to origin, or stepping back towards the average. So return to the origin means instead of trying to predict the dependent variable, we are trying to estimate what should be the the independent variable value, so that we can achieve the respective target. Okay. A line describing this tendency or regress or step back is called as a regression line. So the term regression means returning to the origin, and the line on the graphical line describing this tendency is called as the regression line. Since we can estimate with a fair amount of accuracy the position of this line, it is also called as the estimating line. The term regression was first used by British biometrician Sir Francis Galton in connection with the inheritance of stature. Okay. Galton found that the offsprings of abnormally taller short parents tend to regress or step back to the average population height. But the term regression is now used in statistics is only a convenient term without any reference to biometry. So Sir Francis Galton used it to study the uh, height of the next heir of the abnormally taller short parents. Sometimes we see that parents will be not very heighted, or they will be almost dwarf, but their kids will be of a good height. Sometimes the parents will be too tall, but their children will be short. So it means that the for a dwarf parent, his offsprings being tall goes to the normal population, and for an abnormally tall parents, their heir or children being shorter than them, again it comes back to the normal population. So Sir Francis Galton used to study this concept in order to compare the heights of the such genetic or inheritance in the given population. But today regression is used almost everywhere without the reference of the biometry. Okay. If two variables are correlated, the unknown value of the one variable can be estimated by using the known value of the other variable. So if we have established the correlationship, once we have established the correlation between the two variables, then uh, if you can predict the unknown value of one variable using the known value of another variable. Suppose if you know the future sales value that you have to achieve, so if you know that value, then you can estimate what is the expenditure you should make on the advertisement. Similarly, if you want to know, if similarly you may also reverse that as if I spend this much of money on advertisement, what is the sales that I might get? Okay, so these are two-way questions here. We can answer these questions using the technique of regression. Okay, so the property of the tendency of the actual value to lie close with the estimated values is called as regression. In a wider usage, regression is a theory of estimation of unknown value of a variable with the help of known values of other variables. This definition can be easily understood here. Regression is the theory of estimation of focus the point here. Estimation of unknown value of a variable with the help of known values of other variables. Suppose x and y are given, or suppose say yield and rainfall. So if you want to achieve a certain yield, what is the rainfall you require? So you can estimate that variable value of the rainfall. Okay. Now regression analysis is a mathematical measure of average between two or more variables in the terms of original units of the data. So it is a statistical device with the help of which we are in the position to estimate the unknown values of one variable from the known values of another variable. Okay. In regression analysis, there are two types of variables. The variable whose value is influenced or is to be predicted is called as a dependent variable, and the variable which influences the values or is used for prediction is called as the independent variable. Suppose if you are trying to predict the amount of expenditure to be done in order to achieve a certain level of sales, then sales here will be the independent value because you know that value, and the estimate to be estimated value of the expenditure will be dependent value. Okay. In regression analysis, the independent variable is also known as the regressor or predictor or explanator. So the one which you already the one variable whose value you already know, it is called as the regressor or the predictor. While the dependent variable is also known as regressed or explained. The variable value which you are estimating, that will be called as regressed or explained variable. If the variables in a bivariate data are correlated, we may find that the points in the scatter diagram will cluster in the form of a curve or form a straight line. In the former case, it is known as the curve of the regression, and in the latter case, it is known as the line of the regression, like we saw in the scatter diagram method. Okay. So if two variables are correlated, then we see a straight line there. If they form a straight line, if all the points in the are in the direction of a straight line, then that line will be called as the line of the regression. Okay. Two variables are said to be having a linear relationship when change in the value of independent variable by one unit leads to the constant absolute change in the value of the dependent variable. So we say that the two variables are having linear relationship. Linear means kind of a straight line or unidirectional relationship. When the change in one variable leads to the exact or approximate change in the other variable. When two variables have linear relationship, the regression equations can be used to find out the values of the dependent variables. Okay. So if the two variables are having the linear relationship, then we can use the regression equations to find out the values of dependent variables. The line of the regression is the line which gives the best estimate to the value of one variable for any specific of the other variable. Suppose x, you have the variable x and you have the variable y. For a given value of y, you want to find that variable value of x. Okay. So here y is the independent variable and x is the dependent variable. So line of regression here. So you are trying to find x based on y. Okay. So thus the line of regression is the line of best fit and is obtained by the principles of the least squares. Okay. Now let us look how many lines are there here. For a bivariate data on x and y, the regression equation obtained with the assumption that x is dependent on y is called the regression equation x on y. Okay. Suppose x is a dependent variable and y is the independent variable here. Then that regression equation is called as x on y. X on y means x is dependent on y. And the regression equation x on y is given by x minus x bar is equal to bxy into y minus y bar. Okay. So this bxy is the regression coefficient. Okay. Regression coefficient of x dependent on y. Okay. Similarly, the regression equation obtained with the assumption that y is the dependent variable on x is called as the regression equation of y on x. So y on x means y is dependent on x. Okay. The regression equation of y on x is y minus y bar is equal to byx into x minus x bar. Okay. Here the constants bxy and byx are the regression coefficients. So bxy is the regression coefficient of x dependent on y and byx is the regression coefficient of y dependent on x. So the regression equation of x on y is used to estimate the x values and the regression equation of y on x is used to estimate the y values. Okay. So in the above this here we know the values of y. Okay, y bar. We want to find what will be the value of x for a certain given value of y that will be substituting here. Okay. Similarly, in this equation, we know the x value. Okay. So for this x value, what will be this y value we are predicting here. We are predicting or forecasting the future here. Okay. So now we know that the line of the regression for y on x and x on y are given this. Now we have to here x minus x bar. We are taking the means of x as well as y in both the equations. But we need this value here, bxy and byx. So that is given by the graphical representation of regression equations are called regression lines. So for ungrouped data, in short, it will be given like this. So Bxy is equal to correlation coefficient into standard deviation of x divided by standard deviation of y. Suppose for a given data, you are told to estimate the value of x for a given value of y. Okay, this is a regression coefficient of x on y. And for the same data, if you know the correlation coefficient, if you know the standard deviation of x, and if you know the standard deviation of y, you can use this formula. If you don't know that, if you just have the raw data, then this is the formula here: n into summation of xy minus summation of x into summation of y divided by n into summation of y square minus summation of y whole square. This looks very similar to your correlation coefficient, but there is a difference. In correlation coefficient, in the denominator part, we are considering both x and y terms. Okay, so there you will be having n into summation of x square minus summation of x whole square into n into summation of y whole square into summation of y whole square. But here there is only one term, and this term is related to independent term. What is the independent term here? Y is the independent term and x is the dependent term. You are trying to find the x value based upon this y value. Okay, next byx is equal to, again the same, but there's a change here: correlation coefficient into standard deviation of y divided by standard deviation of x. This again, the numerator part will be same here. What changes here is the denominator part. The denominator contains the values of independent variable here. Here the independent variable is x and the dependent variable is y. Okay, so y is dependent on x. Okay, so this is the formula for ungrouped data. The same again here we will be having the formula for group data. Suppose frequency, bivariate frequency distributions are given, then we will be having this formula: capital N into double summation of xy into fxy, where fxy is the bivariate frequency, fx is the marginal frequencies of x, Fy is the marginal frequency of y, n is the total frequency of a given bivariate frequency distribution. So fxy here is the frequency of both x and y together, like we saw in the previous video of correlation coefficient. Okay, so these are the equations for your regression coefficients. Once you obtain them, you have to substitute them in this value here, bxy and byx, here in the regression lines of x on y and y on x. Now let us look at an example here. Okay, the following data relates to the ages of husbands and wives. Obtain the two regression equations and determine the most likely age of the husband when the wife's age is 25 years, and also determine the most likely age of the wife when the husband's age is 30 years. Okay, so they have given some data points here. So age of the husband is one variable, let us take it as x, and age of the wife is the variable y. Okay, now we need to fit the two regression equations here and also make some predictions here. Okay, so let us look at how they have solved the problem here. Now these are the given values of x, and again they have taken the u and v values. Okay, so the deviation values here, since the values are bigger here, so if they have taken like this, so u is equal to x minus 35. Every x value has been subtracted from the 35, and every y value has been subtracted from 30. So the results are minus 10, minus 7, minus 5, minus 3, 0, 1, 3, 4, 7 and 10, which totally yields you the answer 0. Next. Next. V value, that is minus 10, 4, minus 4, minus 1, 0, minus 5, minus 12, minus 4, 5, 5, 16. The answer is minus 10. Next. The u values have been squared here, the v values have been squared here, and again we require uv. Let us look at how it has been substituted here. First, the means are taken here, so the mean values are taken directly. So x bar is equal to summation of x by n, so 350 by 10 is 35, and y bar is equal to summation of y by n, 290 by 10, that is 29. So bxy, bxy here, we have actually the original formula that we have is n into summation of xy minus summation of x into summation of y divided by summation of y square into n minus summation of y whole square. Here, instead of writing in place of x, they have written u, and in place of y, they have written v. So n into summation of uv minus summation of u into summation of v divided by n into summation of v square minus summation of v whole square. So that is 10 into 324 minus summation of u is 0 here, into minus 10, summation of v is minus 10, divided by 10 into 608, summation of v square is 608, and summation of v whole square, so minus 10 square is 100 here. So the total answer here is 0.5418. This is x on y, the regression coefficient of x on y. Now similarly, the regression coefficient of y on x, that is given by n into summation of uv minus summation of u into summation of v divided by n into summation of u square minus summation of u whole square. So 10 into 324 minus 0 into minus 10 divided by 10 into 328 minus 0 square. So that yields you the result 0.905. Now that we have estimated the regression coefficients here, we shall go for the estimation of the equations. So the regression first, the regression equation of x on y is given by x minus x bar is equal to bxy into y minus y bar. So that is x minus 35 is equal to bxy value is 0.5418 into y minus 29. So x is equal to, if you multiply this 0.5418 with y and 29, that is taking away the brackets and multiplying them, and bring the 35 this side, that will be x is equal to minus 0.5418 y minus is equal to 0.5418 y minus 15.7122 plus 35, which finally gives you the result x is equal to 0.5418 y plus 19.2878. Now in the question they had given to estimate the value of x when y is equal to 25. We have a y here, so in this equation if you substitute the value of y, you will get the value of x here. So x is equal to 0.5418 into 25 plus 19.2878. Okay, so 32.83 is the answer of x. That is, the y belongs to the age of wife. So they had asked you a question, what will be the age of husband if the wife's age is 25? So there the age of the husband will be 32.83, that is approximately 33. Next, the second equation to be fit here is the regression equation of y on x, that is y minus y bar is equal to byx into x minus x bar. So y minus 29 is equal to 0.905 into x minus 35. Similarly, taking away the brackets and multiplying this 0.905 with x and 35 and taking the 29 this side, we have y is equal to 0.905 x minus 31.675 plus 29. So that is y is equal to 0.905 x in minus 2.675. Now, in the question, they had asked to estimate the value of y for given x value. So the given value here is 30. So what will be the value of y if x is 30? Then in this place of x, we are writing 30 here. So 0.905 into 30 minus 2.675, that is 24.48. So that is when the age of the husband is 30, the age of the wife will most likely to be approximately 24 years. So this is how you obtain the two regression equations and you estimate the value of one equation, one variable based upon the other. Okay. In some questions, they might also not ask to fit the both equation. They might just ask you to fit only one equation, which in this case is only y on x. So here we don't need to find all the values, just find x, y, x square and xy. So that they yield you the results 36, 60, 266 and 293. So the regression equation for y on x is y minus y bar is equal to byx into x minus x bar, where byx will be given by n into summation of xy minus summation of x into summation of y divided by n into summation of x square minus summation of x whole square. So that is minus 0.402 divided by 30, which is minus 1.3333. So regression equation of y on x is this one. So y minus 10 is equal to minus 1.3333 into x minus 6. So that yields you completely the result y is equal to minus 1.33x plus 17.9998. Okay. So this is how you are fitting a regression equation for ungrouped data. Next, we shall look at how to fit a regression equation on a group data. Now here they have given you a grouped data. Okay, so this is one variable x, the height, and this is another variable, say weight. Okay, now you have been asked to fit a the regression equations of x on y and y on x. Okay, so now since there are intervals here, we take the midpoints of those intervals. So 52.5, 57.5, 62.5 and 67.5. Similarly here 90 to 100, 95, 100 to 110, 105, 110 to 120, 115 and 120 to 130, 125. Now what has been done here is, here instead of taking the x values, since they will be very large and multiplying them will not be feasible, so the values have been converted to u. The x values have been converted to u, that is all the values of x have been subtracted from 57.5 and divided by 5, since the common difference between the two, any two consecutive x values is 5. So subtracted by 57.5 and divided by 5. So 52.5 minus 57.5 is minus 5. Minus 5 divided by 5 is minus 1. Next one will be 0. Next 62.5 minus 57.5 is 5. So 5 divided by 5 is 1. Next 67.5 minus 57.5 is 10. 10 divided by 5 is 2. So again the same procedure, u into fx, that is this column into the frequency. The frequencies are the total here 4 plus 7 plus 5 plus 2, that is 18. So 18 into minus 1 minus 18. Next 6 plus 10 plus 7 plus 4, 27. 27 into 0 will be 0. Next 6 plus 12 plus 10 plus 7, 35. 35 into 1 will be 35. So 3 plus 8 plus 6 plus 3, 20. 20 into 2 will be 40. Similarly, u square into fx. Square the u terms and multiply them with fx. So 18, 0, 35 and 80. And at last u into v into fxy. This looks very similar to your correlation problem here. So uv. So u is minus 1. Similarly here y values have been converted into v. Okay, so that is 105. The common here taken is 105. So 95 minus 105 is 10, minus 10, and minus 10 divided by 10, because since the difference between any two consecutive values of y is 10. So 95 minus 105 divided by 10, minus 1, 0, 1 and 2. So now it works such that u into v into this scale here. So minus 1 into minus 1 into 4, that is 4. Minus 1 into 0 into 7, that will be 0. Minus 1 into 1 into 5. Minus 1 into 1 will be minus 1. Minus 1 into 5 will be minus 5. Minus 1 into 2, that is minus 4. So you have to multiply here u values into v values into the frequencies. So that value we have to write in the bracket here. Okay. Next all will be 0, since here it is 0. Next 1 into minus 1 into 6, minus 6. So 1 into 0, that will be 0. 1 into 1 into 10, 10. 1 into 2 into 7, 14. Next 2 into minus 1 into 3, minus 6. This one will be 0, since 0 is involved here. Next 2 into 1 is 2, 2 into 6 is 12. 2 into 2, 4, 4 into 3 is 12. Okay, so now we count all the numbers written in the windows here. So minus 5 minus 4 is minus 9. Minus 9 minus plus 4 is minus 5. Next one will be 0. Next 10 plus 14, 24. 24 minus 6, 18. 12 plus 20, 12, 24. 24 minus 6 is 18. So 18 plus 18 minus 5, 36 minus 5 is 31. So this we have solved for x. Now similarly we solve it for y. Like I told you, the values have been converted here. So instead of taking the y values, v values have been taken. Now the v values are minus 1, 0, 1 and 2. So v into v into fy. Minus 1 into 19, minus 19, 0 into 37, 30, 0, 1 into 28, 28, 2 into 16, 32. Its total is 57, 41. Next, v square. 1 square into 19. 19, 0 square it will be 0. 1 into 1 square into 20 is 28. 4 into 16 is 64. That results into 111. And at last, u into v into f of xy. So there are already the numbers have been calculated while calculations for x, so you don't need to calculate it again. You just have to write the totals in the windows here. So minus 6 minus 6 minus 12, and minus 12 minus 4 is minus 8. This one will be 0. 10 plus 12, 22. 22 minus 5 is 17. So 14 plus 12, 26. 26 minus 4 is 22. So 17 plus 22 minus 8, that will be 31. Again here this column and this column here both should give you the same totals, 31 and 31. Now based upon this table you can calculate the mean value here. So the mean value here will be given by, what is the mean value, what is the mean for the subdivision method for the data? X bar is equal to a plus summation of f into u dash divided by n into c. So or u bar into c. Your u bar value here is 57 by 100 into 10. So the mean value, the x value, mean value is 60.35. Similarly, the mean for the variable y is b plus d into v. In the x we have taken a, here we take the value as b. So 105 plus 10 into 41 by 100, that is this column has been taken here. V into, this is similar to your f of f into x, here v into fy. So 41, that results into 109.1. Now we estimate the uh, coefficients here, regression coefficients. So since we have changed the scale here, we have changed the scale, that is u dash, we have taken the u dash. So we have to take this ratio here. For bxy it should be c by d, and for byx it should be d by c. So that is c by d into n into double summation of u into v into f of xy minus summation of u into fx into summation of v into fy divided by n into summation of v square fy minus summation of v fy whole square. So c by d 5 by 10. So 5 by 10 is 0.5 into 100, 100 into 31 minus 57 into 41 divided by 100 into 111 minus 41 square. So that results into 0.05 into 0.081, that is 0.0405, the value of bxy. Similarly, the value of byx is d by c is equal into n into double summation of uv into fxy minus summation of u into fx into summation of v into fy divided by n into summation of u square fx minus summation of u fx whole square. So that is 2 into 100 into 31 minus 57 into 41 divided by 100 into 133 minus 57 square. So that results into 2 into 0.0759, that is 0.1518. Now estimating the equations here, the regression equations, x on y is x minus x bar is equal to bxy into y minus y bar. X minus 60.35 is equal to 0.05, the value of bxy, into y minus 109.1. Similarly, x is equal to, so now taking this, solving this bracket, taking this 0.045405 inside and multiplying with them, we have x is equal to, take 60 here. So 0.045 0405y minus 4.4186 plus 60.35. So that results into x is equal to 0.0405y plus 55.93. Now for a given value of y, you can estimate the value of x using this equation. Similarly, the regression equation of y on x is y minus y bar is equal to byx into x minus x bar. That is y minus 109.1 is equal to 0.1518 into x minus 60.35. Now solving this bracket and taking this 109.1 here, we will be having y is equal to 0.1518x minus 9.1611 plus 1019.1. That is equal to y is equal to 0.1518x plus 99.9389. So if you want to find any value of y for a given value of x, we use this equation. So this is how we fit or we calculate the regression equations for the given frequency, bivariate frequency distribution. Let us look at some of the simpler problems here. In correlation analysis between production and price of a commodity, the following data are obtained. So here there are two variables, production index which is x and price index which is y. So the arithmetic mean for production index is 110 and for that of price index is y. The standard deviation here is 12 for production index and for price index it is 5. The correlation coefficient between the production and price is minus 0.4. Write down the regression equation for price on production and estimate the price index when the production is 116. Basically, they have given you the data here and they have asked you to find the equation y on x. Price here is y and production is x. They have asked you to find the equation of price on production and asked you to estimate the price when the production is 116. Now let us look at the problem being solved here. Okay. Now here we have the correlation coefficient as well as the standard deviations. Hence our b by x, we need the regression coefficient. Our equation here will be y minus y bar is equal to byx into x minus x bar. So byx, we had another formula, that is when we have the correlation coefficient and standard deviation, we can go for this formula here. So correlation coefficient into standard deviation of y divided by standard deviation of x, that is minus 0.5 into 5 divided by 12, that is 0.1667. Now we already have the x bar value and the y bar value. Therefore, the regression equation of y on x is given by y minus y bar is equal to byx into x minus x bar. That is y minus 98 is equal to minus 0.1667x minus 110, which results into y is equal to minus 0.1667 into x plus 116.33 116.337. This is the regression equation of y on x. Now we have been asked to estimate the value of y when x is 116. So y is equal to 0.1667 into 116 plus 116.337, which sums up to 96.9998 or approximately equal to 97. Therefore, the when the production index is 116, the price index will be 97 is the answer. Now let us look at some important properties of regression coefficients. Regression coefficients are independent of the variables in the regression equations. Okay. Now the regression coefficient bxy is a change occurring in x for a unit of change in y. So bxy means if y changes per unit, then the same change happens in x as well. Similarly, the regression coefficient of byx means the changes happening in y for every unit change in x. Okay. The regression coefficients are independent of change of origin but not of scale. Now if you take u is equal to x minus a, that is okay. You can do it without any additions there. But if you take u dash is equal to x minus a divided by c, then you have to again multiply the final answer with the c again, like we saw in the previous example. Okay, so change of origin doesn't alters the answer of regression, but change of scale does. Hence, it is dependent on the change of scale. The geometric mean of regression of coefficients is equal to the coefficient of correlation. So, numerically, that is, correlation coefficient is equal to plus or minus square root of bxy into byx. Okay, since here while estimating the regression coefficients, we involve the correlation coefficient. Therefore, a correlation coefficient is nothing but the square root of the products of both the regression coefficients. Okay, we know that the regression coefficients are given by this. Therefore, bxy into byx is equal to correlation coefficient of standard deviation of x divided by standard deviation of y into correlation coefficient of the standard deviation of y divided by standard deviation of x. So that results into bxy into byx is equal to correlation coefficient square. Therefore, correlation coefficient is equal to root of bxy into byx. Okay. So this is the relation between correlation and regression. Next, since the coefficient of correlation numerically cannot be greater than 1, the product of regression coefficients cannot be greater than 1 as well. Since regression itself is not greater than 1, then obviously the products of the regression coefficients will also not exceed 1. That is, even if one regression coefficient is greater than 1, then the other one will be definitely less than 1. Okay. The two regression coefficients cannot be of opposite signs. So if bxy is negative, then byx will also be negative. It's not like both one will be positive and one will be negative. No chance. Okay. So either both will be negative or both will be positive or both will be 0. Okay. Then now how it is affected by correlation? If the data is positively correlated, then the regression coefficients will be positive. Okay. If the data is negatively correlated, then both the regressions will be negative. If it is zero, the correlation is zero, then both the the regression coefficients will be zero. Okay, these were the properties of the coefficients. Now let us look at the properties of the regression lines. So two regression lines intersect at x bar and y bar. For correlation we saw that there is only one line we draw. Okay, now for regression there will be two lines. One is for the equation of x on y and another one will be y on x. Okay, so both the lines will intersect at the mean values of the variables respectively, that is x bar and y bar. Okay, if variables are positively correlated, then the regression lines will have a positive slope. When the slope is negative, the variables are negatively correlated. Positive slope means from down bottom left to uh, right upper corner. If the direction of line is like this for both the lines x and y, it means there is a positive correlation between them. If the lines are from left top corner to right bottom corner, that means the data x and y are negatively correlated. Suppose if there is a perfect correlation, then the regression lines will coincide. If there is perfect correlation, then the two lines will merge with each other and become one. Next, if the correlation does not exist, then the two regression lines are perpendicular to each other. Okay, that is, there is no relation between the line x and line y. Okay, so these are the properties of regressional lines. Now what are some basic uses of regression? Regression analysis helps in establishing a functional relationship between two or more variables. So regression analysis provides an estimated value of dependent variable for the given value of independent variable. This can be used for predictions, estimating of future production, price, sales, investment, income, profit, etc. It is of immense use in business forecasting. So regression is very useful, a very useful technique, a very mathematically significant technique when it comes to predictions or estimations. Okay. Next, second one is, with the help of regression coefficients, we can calculate the correlation coefficient, which measure the degree of correlation that exists between the variables. For a data, for a given data, if you don't know the correlation, still you can measure the correlation when by using the regression coefficients. Regression analysis is widely used in statistical estimation of demand curve, supply curve, production function, cost function, consumption functions, etc. That is, regression is having very great uses in economical activities. Okay, so these are some of the important uses of regressions. Now let us look at what is the difference between correlation and regression. Okay, correlation deals with the association between the two or more variables, whereas regression deals with the appropriate functional derivation of the relation between the variables. That is, correlation tells you the degree of relationship between two variables, whereas regression helps you in estimating the change in one variable due to the change in the other variable. Correlation need not apply the cause and effect relationship between the two variables under study. Now you had studied previously that for there is a causation. Causation means cause and effect relationship between the two variables. So in a correlation, there is not necessary that there should be a cause and effect, but if there is a cause and effect, there will definitely be a correlation. This is what we studied in correlation. But for a regression analysis, it clearly indicates the cause and effect relationship. Okay. The third one is, there may be nonsense correlation between two variables, which is purely due to chance and has no practical relevance. But there is nothing called as nonsense regression. Regression clearly is applicable, clearly gives you some relationship between the two variables. Okay. Now the correlation coefficients Rxy and Ryx is symmetric. That is, if you write Rxy or Ryx, both are same. Okay, but here bxy has different meaning and byx are having different meaning. Bxy means x depending upon y, and byx mean y depending upon x. So you can't say both are same here. Okay, and at last, correlation coefficient is independent of change of scale and origin. So regression coefficients are independent of chain but not of scale. For a correlation coefficient, if you take u or u dash, still it will be same. Whereas for regression coefficients, u and u dash differs, and it differs very significantly. So this was all about the regression theorem. Let us look at an example here. So if two regression coefficients are given as bxy is equal to minus 3.4 and byx is equal to minus 1 by 3, then we need to find the correlation coefficient here. So correlation coefficient is equal to root of bxy into byx, that is minus 0.34 into minus 1.3, that is 0.5. Now in the previous points we had explained that if the correlation between the two values, that is, sorry, the correlation between the two variables is negative, then both the regression coefficients will also be negative. We see here that both the regression coefficients are negative, so the final answer should be a negative answer here. Hence they have taken the absolute value for the calculation, and when you calculate they will be positive numbers only, but since both of them are negative, that means the correlation is negative here, so we write the final answer as a negative number here. So that final answer yields into 0.5. So that means 0.5. So minus 0.5. So this is how you find the correlation coefficients using the regression coefficients. Okay. Similarly, estimate the value of x when y is equal to 20 using the following data. So x and y, both the values are given. So for them the mean and standard deviation is given and the correlation coefficient is also given. So we know that the x on y equation uh, is given by x minus x bar is equal to bxy into y minus y bar, where bxy is equal to correlation coefficient to sigma x by sigma y, that is equal to 0.8 into 5 divided by 4, that is equal to 1. So now that we have estimated the regression coefficient, we shall go for the further thing. X minus 25 is equal to 1 into y minus 30, that is x is equal to y minus 30 plus 25. Therefore x is equal to y minus 5. So if we take the value here, when y is equal to 20, then x is equal to 20 minus 5, that is 15 is the answer. At last, now if two regression equations are 3x plus 5y is equal to 3 and 4x plus 3y is equal to 4, then find the mean values of x and y and also the coefficient of correlation between x and y. So we are given that 3x plus 5y is equal to 3 and 4x plus 3y is equal to 4. Now if we solve this equation simultaneously, okay, so if we solve this simultaneously, that either we cancel out the x first or y first. Okay. So if you solve both 1 and 2 simultaneously, then we will get the y value as 0, and substituting that y value in any one of the equation, then we will get the x value as 1. So that means x bar value and y bar value. X bar is 1 and y bar is 0. Now consider the first equation here. 3x plus 5y is equal to 3. So if we solve it here, if we take the constant part outside, 3 and 5, okay, so that will be, take the 3x this side, it will be 3 minus 3x. What remains here is 5y, and 3 minus 3x, out of that take 3 common outside, so you will be having uh, 3 into x minus 1, sorry, minus 3 into x minus 1. So if you take the 5 this side here, that will be minus 3 divided by 5 and into x minus 1. So byx is equal to minus 3 by 5. Similarly, if we consider this equation here and if we turn it, it will be x is equal to minus 3 by 4 into y plus 1, where the bxy will be minus 3 by 4. Okay. So now that we have obtained the two regression coefficients. Therefore, the correlation coefficient is equal to root of bxy into byx is equal to root of minus 3 by 4 into minus 3 by 5 is equal to 0.6708. So since both the regression coefficients are negative here, therefore the correlation answer will also be a negative number. So this is the concept of regression. Okay. So this is all about analysis of bivariate data, that is the correlation and the regression concept.